Welcome to Lemon Code 21. In this tutorial, we will explore how to build a powerful GraphQL API using the FastAPI framework, along with PostgreSQL as the backend database. GraphQL. What is GraphQL? GraphQL is a query language for API, application programming interfaces, and a server-side runtime for executing those queries. Sure, let's get started. To begin, open your preferred ID. I'll be using Cycarm in this demonstration. Open your ID and navigate to the project settings or options. Look for the option to add a local interpreter for your project. Choose this option. Create a virtual environment for your project by selecting the appropriate option and confirming. With the virtual environment set up, it's time to add the necessary libraries to your project. We'll need several libraries to build our FastAPI application. Install FastAPI and Uvicorn to create and run the FastAPI application. Schema, School Model, and Scicop2 libraries are used for database connectivity and ORM. Python dotenv. This library helps you load environment variables from a .env file. Strawberry GraphQL. Install Strawberry, a Python GraphQL library for FastAPI. Now, let's create a main.py file. This will serve as the entry point for our FastAPI application. In the main.py file, create a FastAPI app with some basic metadata. In the FastAPI method, we can add title, description, and version. Then we add a simple endpoint that is home with the return string, welcome home. Finally, add the main block to run the FastAPI app using Uvicorn. This will start the FastAPI app and make it accessible at localhost 8888. Let's run main Python. We open it in a browser on localhost 8888. The result is that the home endpoint is already accessible. Now let's create the config.py file. First, we will load the database connection URL from a .env file. In this .env file, we'll define a variable with the URL for the desired database connection. Next, we'll define a database session class. Within this class, we will create an schema engine using the createAsyncEngine function, passing it the database URL. We'll also define a session local variable using the session maker function from Squawkemy's ORM. This local session will be used to interact with the database. We'll then create a createAll method to generate the database tables based on the defined models. Additionally, we'll implement a drop_all method, similar to createAll, but instead it will drop the tables. A close method will be included to disconnect from the database. Furthermore, we will define enter and exit methods to handle asynchronous context management for database sessions. Lastly, we'll add functions for committing and rolling back transactions if needed. Returning to the main file, we'll add two functions, startup and shutdown. In the startup function, we will execute the createAll method from the database session class. In the shutdown function, we will call the close method from the same class to ensure proper shutdown of the database connection. This setup in the config.p, y, and main files will establish a connection to the database, generate tables, and handle graceful startup and shutdown processes. Sure, let's run it. The result is still an error because we haven't installed the async module. Okay, we have successfully run our application. We have connected to the PostgreSQL database. Create model layer. Sure, let's proceed. First, create a new Python package named model. Inside this package, we will define a model class called Note using schoolModel. In this code, we've created a model class named Note within the model package. We've defined 3 attributes for the Note table: id as an integer primary key, name as a string, and description as a string. This model class will represent the structure of the Note table in your database. Remember to ensure that the necessary dependencies, such as schoolModel, are properly installed in your environment. Feel free to adjust the model attributes and structure according to your specific requirements. Create repository layer. Let's create the repository package right away. Add a file named note.py within. Create a class named NoteRepository. Firstly, we'll create the create function using a static method. Its purpose is to store note data. We'll retrieve .v from the configuration using an async approach and use the session. Begin method to initiate a session. Next, we'll add data using the add function. Finally, we'll include the commit rollback function, which is used for rolling back if an error occurs during input. Next, we'll create the get function to retrieve data based on the note ID. Use an input parameter named noteID with an integer data type. Then call the DB variable as the session from the configuration file. Perform a select query and execute the select query. After that, let's create the all function. The process is almost the same as the get function, with the query being the only difference. Moving on, we'll create the update function with two input parameters, noted of integer data type and note data type, with note data type from the note table data type from the note. As usual, we'll create it using an async approach and call the W variable as the session. Next, we'll craft a query to search for data by ID to determine if the data exists or not. If it does, we'll modify the name and description values according to the input parameters from note data. Afterwards, we'll execute the update query. Lastly, in the delete function, we'll follow the async approach and call the W variable as the session. Create a delete query and execute it. Create service layer. Next, let's create the service layer. But before creating the service layer, let's first create the schema as the data that will eventually become the input for Strawberry GraphQL. Let's proceed by creating a notatype class with the Strawberry decorator at Strawberry. Type, which will function as the returned data structure. After that, let's create a note input class that will be used as input data in GraphQL. Once these are set up, we can create a service package. Don't forget to include a note file within the service package. Then, create a note service class. First, let's create the add note function. This function will take a parameter called input note data with the data type of the note input schema object. After that, we will map the object to a node object, which has the data type of school model. Next, we'll call the create function from the node repository class to execute the addition of the node. The return value of the add note function will be created with the data type of the nodetype object from the schema. Next, let's create the getAllNotes function without requiring any parameters. Then we'll retrieve all data by using the getAll function from the node repository class. Since the data is in the form of a list, we will remap all the data in the list to the list nodetype data type from Strawberry. Moving on, let's create the getNoteById function with an input parameter of type integer. Call the getById function from the node repository class. We will remap the nodetype as the return value. Next, in the deleteNote function, provide an input parameter named noteId with an integer data type. After that, call the delete function from the node repository class. We only need to create a return value in the form of a regular string. Lastly, let's create the updateNote function with input parameters, an integer for the note ID and an object schema nodetype. We will remap the data to the SQL model object node and then execute the update function from the node repository class. The return value will be a regular string. Create GraphQL layer. Every GraphQL API has a schema, and that is used to define all the functionalities for an API. A schema is defined by passing three object types: query, mutation, and subscription. Mutation and subscription are optional. Meanwhile, query has to always be there. In this tutorial, I only use two objects, namely mutation and query. Next, let's create the GraphQL layer. This GraphQL layer will be divided into two files, query and mutation. First, we'll create the query file. Start by creating a query class and adding the @strawberry. Type decorator. Let's create an example endpoint called hello by implementing a hello function that returns a string. Don't forget to add the @strawberry.fieldDecorator as well. Moving on, let's add a getAll function with the return type of a list of note type from the schema. Simply call the getAllNotes function from the note service class. Again, remember to include the @strawberry.fieldDecorator. Lastly, we'll add a getById function that takes an input parameter ID of type integer and returns a note type from the schema. The process is quite similar. You just need to call the getNoteById function from the note service class and add the @strawberry field decorator. Alright, we've covered all the endpoints in the query section. Now, let's move on to the mutation section. In the mutation file, create a mutation class with the @strawberry.typeDecorator. Then, add a createNote function that takes an input parameter note data of type note input from the schema and returns a note type. Don't forget to use the @strawberry.mutationDecorator. The process here is similar. Just call the addNote function from the note service class. Next, add a deleteNote function that takes an input parameter noted of type integer and returns a string. Utilize the deleteNote function from the note service class. Finally, create an updateNote function that takes two input parameters, noted of type integer and note data of type note input from the schema. Return a string. Use the updateNote function from the note service class. With all the endpoints in place, let's proceed to the main file. Add a GraphQL endpoint in the main file. Create a variable named schema and assign it the value of the strawberry. Schema function, which includes both the query and mutation sections from the GraphQL layer. Then, create a GraphQL variable and include the schema within its constructor. Finally, integrate the GraphQL router into the FastAPI app. Place the router within the app's routers. Alright, we've completed the implementation. Now it's time for testing. Sure, it's time to perform testing. Let's start by running the application. Once you see that the note table has been generated in the database by Squalchemy, open your browser to check if localhost is up and running. Next, navigate to the GraphQL endpoint. You'll see the user interface displayed. Now, let's test the query by posting data. Choose the mutation section and look for the Create Note mutation. Enter the name and description values, then submit the request. In this interface, you can also select which columns you want to display. To view all the data, select the Query section and use the Get All query. As you can see, all the data is displayed. Let's try the Get by ID endpoint by selecting an ID, let's say 2. You will see the specific data for that ID. Now, let's test the Update functionality. Choose the Mutation section and find the Update Note mutation. Try updating the data for a note with id of 1. After updating, check the data again using the Get All query. You'll see that the data has been successfully changed. Lastly, let's test the data deletion. Choose the Mutation section and select the Delete Note mutation. Try deleting data with an ID of 2. After the deletion, verify the result by checking all the data using the Get All query. You will notice that the data with ID 2 has been removed.